Hi, in this video, I will be showing you problem number 1110, example of 1110, which is finding the Maclaurin series for sin x. This is example number 4 from 1110. So find the Maclaurin series for sin x. Find all the values of x for which the series for sin x converges. Maclaurin series is f of x equal to f at 0 plus f prime at 0 divided by 1 factorial times x plus f double prime 0 by divided by 2 factorial times x square and so on. Then nth derivative, any generic term would look like f of nth derivative of f at 0 over factorial n times x to the power n and so on. So let's create a table where f of x equal to sin x and f at 0 is sin 0 equal to 0. The Maclaurin series is all about finding the values of the function f and its derivative at 0. So we'll create a table for all these. F prime x is cosine x and we'll find out the value at 0 which is equal to 1. We notice that only the odd derivatives values are existing and they alternate. The even derivatives and the function at 0 are all 0. So if we plug in all these values into step A, into this step, we'll plug in all the values from the table into this step. We get fx equal to 0 plus 1 over factorial 1 x plus 0. Then the third derivative, that would be negative 1 over factorial 3 x cube and so on. So it will become 0 next term. The next term would be positive 1 over factorial 5 x to the 5. So it alternates sign and you get only odd exponents for x. So whatever the exponent is, that is the same thing with factorial representation in the denominator. So we get fx equal to x over factorial 1 plus minus x cube over factorial 3, x to the 5 over factorial 5 and so on. So this can be written in a simpler manner in the sigma notation. Fx is sin x, by the way. Sigma n varying from 0 through infinity. Negative 1 to the power n x to the power 2n plus 1 over factorial 2n plus 1. This is step B. All it remains to be proved is what the radius of convergence is. So we will do the radius of convergence by taking the ratio test. So we'll find out an plus 1 over an and then we'll allow n to approach infinity, which is negative 1 to the power n plus 1 over x to the power 2 times n plus 1 plus 1. Note, n here must be replaced by n plus 1, so you need a parenthesis. So that's what we have done here, plus 1 divided by 2 times n here gets replaced by n plus 1 within the parentheses. So n plus 1 factorial. We are dividing that with an. So I take this term and then multiply by the reciprocal. So it is 2n plus 1 factorial divided by negative 1 to the power n times x to the power 2n plus 1. So we get negative 1 to the power 1. Then these would be x to the power 2n plus, then this will become a 2 and this there is another 1 outside. So it will be 2 plus 1, so it will be a 3 divided by same thing here 2n plus 3 factorial, then 2n plus 1 factorial on top. Denominator is x to the power 2n plus 1. We'll further simplify these, keeping in mind We are taking anyway the absolute sign eventually, so this term would go away. Negative 1 would become, absolute of negative 1 would become positive 1. And here we have x to the power 2n plus 1, x to the power 2n plus 3. That would become x square. So you get absolute, you get x square over there. Then this 2n plus 3 factorial can be written as 2n plus 1 factorial times 2n plus 2 times 2n plus 3. So 1 2n plus 1 factorial would get crossed out. So the denominator would be just 2n plus 2 times 2n plus 3. Now I'll take the absolute value and then allow n to approach infinity. It will be just 1. Absolute of negative 1 would be 1. So x squared divided by 2n plus 1 times 2n plus 3, a limit n approaching infinity. This would be equal to 0 for all x. But according to limit ratio test, if the limit value is equal to less than 1, then the series converges. But we know that the limit is equal to 0 for all values of x. So for all values of x, the series converges. So radius of convergence equal to infinity, and sin x, which is f of x, equal to sin x, as the representation that we derived in part B, which is sigma n varying from 0 through infinity, negative 1 to the power n, x to the power 2n plus 1 divided by 2n plus 1 factorial, which converges for all x, which is what we mean by radius of convergence being equal to infinity. Hope this video helps.